Hi everyone. This video is going to be about the phases of matter. Please take notes on a new sheet of paper or a new Google Doc and put it inside the Unit 1 divider or Google Drive folder, Unit 1. This is continuing from yesterday's notes about matter and the conservation of mass. All right, before we begin, some things to recall. Matter is anything that has mass and volume. Matter has intrinsic properties, which means it doesn't depend on how much matter you have, and extrinsic properties, which does change depending on how much you have, like mass and volume. Matter cannot be created or destroyed, and that's the law of conservation of mass. This means, for this PowerPoint, what those three things tell us is that all phases of matter have mass and volume. A lot of times people forget that gases have mass. So all phases of matter have mass and volume, including gases. And mass doesn't change if something changes its phase. And I know that's blocked by my beautiful face, but mass doesn't change if something changes its phase. So if something like ice were to melt and become water, it doesn't change its mass. All right, so we know solid, liquid, and gas, right? Those are the three main phases we're going to talk about. I'm going to talk about them in order of decreasing energy. So, gas phase. Gases have no particular shape and no particular volume. That seems strange, but it's because they fill up their container completely. If I put a gas into a beaker with an open lid, it would come out and it would fill up the entire room. If you put it inside of a bottle and you put the cap on the bottle, the gas is the shape of the bottle. That's because gases are mostly empty space. A lot of people think that in between the atoms of a gas is air. That's not true. Air is actually a gas. It's a mixture of gases. And in between the atoms is nothing. It's empty space. It's a vacuum, just like outer space is a vacuum. That means that you can compress it. You can squeeze gases together because you can take up some of that empty space and push those atoms closer together. That means it's compressible. Atoms in a gas move very fast. They're bouncing all around. They have the most energy. So that energy actually overcomes the attractive forces that kind of pull the atoms together. Atoms, they naturally want to be kind of close to each other. They're attracted to each other. Just like, planets are attracted to the sun. Atoms and molecules are attracted to each other. But gases have so much energy that it overcomes the attractive force between them. So they bounce all around. Liquid phase. That's this one. Liquids have no particular shape, but they do have a definite volume. They fill up the bottom of their container. The atoms get close enough together that gravity actually pulls them down to the bottom of whatever container they're in. So if I have a graduated cylinder like this, the volume of the liquid will fill up the bottom of the container, not up here at the top, not in the middle. It goes to the bottom, but it takes the shape of whatever container you have, whether it's a cylinder or a beaker or a flask or whatever. The atoms are actually close enough that they touch each other a little bit. It's sort of like one of those games that kids play in the car, like, I'm not touching you, I'm not touching you. They touch, but they don't actually stick together. This means that they can't be compressed because there's not enough space in between those atoms to make them squeeze together even closer. They are as close together as they can get. Atoms have enough space where they can have a little elbow room and they can flow. So they can move around. They can move from one end of the container to the other. They have lower energy than gases. The attractive forces that pull the atoms together are actually acting on liquids. They don't have enough energy to overcome that. So liquids have what we call intermolecular forces. That's the attractive forces that hold particles together. For solid phase, let me move my little thing here. For solid phase, solids have a definite shape and a definite volume. They're rigid, they keep their shape. The atoms are extremely close together. In fact, this is the closest the atoms can get. They bump into each other and they're so tightly packed that they are just about touching. So they cannot be compressed. They cannot be squeezed closer together. Atoms are still in constant motion. Atoms of any phase are in constant motion, but they're not moving around. They're not flowing from one side to the other side. They don't move and change their place. They stay in one place. They just jiggle. Solid phase has the lowest energy and the strongest attractive forces. Some other phases of matter that you might have heard of, but we don't really think about them until chemistry class, is plasma. This is actually the most common form of matter in the universe. Stars, which is like most of the matter in the universe, are actually plasma. And I'm just realizing that stars probably aren't the most common matter in the universe because of dark matter and things that we don't really know about yet. But of the matter that we can observe, stars are made out of plasma. And so what is a plasma? Plasma is when gas atoms become so hot that they actually break apart. The atom can split up into electrons, which you probably have heard of before, and positive ions, where you have the positive nucleus with some electrons there, and those positive ions and negative electrons, they fly around and they're super excited. They have the highest energy, but they can be controlled by magnetic fields. There are lots of there are several phases of matter, and I don't know about them, to be honest. But one that I would want to share with you is Bose-Einstein condensates. These things are crazy weird. So what happens is you take some, only a dozen atoms of a gas, something, very, very small sample of gas, and we actually use lasers to cool them down. The lasers can cause the atoms to stop moving a little bit at a time. They can just pulse the laser and the atoms stop moving. As they always move, but they don't move as much. And so you slow them down, it gets colder and colder and colder until it's very close to absolute zero, just a few hundredths of a degree above absolute zero. And what happens is the atoms become so cold that they begin to act like a single atom. They don't fly around, they don't bump into each other, they don't just sit there and jiggle. They actually move in unison as if they were a single atom. Very crazy, very awesome. So one last note for this PowerPoint before I sign off is that if we change phase from solid to liquid to gas, from gas to solid, from liquid to gas, from liquid to solid, these phase changes we're going to talk about in a lot more detail in Unit 3 when we do heat. But phase changes are physical changes, right? So think about ice. Ice is water that's a solid. And if it melts and it becomes liquid that you can put in a glass, it's still water. Physical changes are when matter changes its form, but not its identity. It is still the same chemical that it was before. So H2O solid, H2O liquid, H2O gas, the atoms still look the same. It's not changing the molecules where the atoms are bonded together. They're still staying the same. It's just that they're moving around more or they're moving around less and just jiggling. It's how much they're moving and how free they are to move around. So that was my little PowerPoint, and I managed to keep it short for you. I hope you took some notes. It's not necessary to take notes of every single word that's on the page because I'll push this PowerPoint to you. And you can watch this video as many times as you like, but filling in some of the blanks, the things that I said, is the important part to capture here in your notes. So these notes go in Unit 1, they're a continuation of our notes on matter, and I hope you have a good day. Now can I figure out how to turn this off? Old people with technology.